Hello everyone, welcome back to our channel SKM Tutorials Hub. In today's video, we are diving into one of the fundamental sorting algorithms, that is bubble sort. Whether you are a beginner just getting started with algorithms or someone looking to brush up on your basics, this video will walk you through everything you need to know. Now, what is bubble sort? Bubble sort is a simple comparison-based sorting algorithm. It works by repeatedly stepping through the list to be sorted, comparing each pair of adjacent items and swapping them if they are in the wrong order. This process is repeated until the entire list is sorted. For understanding the bubble sort algorithm in a better way, we will be discussing it with an example. But before moving on, if you are new to this channel, then please subscribe to our channel and also press the bell icon for getting the latest updates. As an example, we will take a list of 10 numbers here. We need to keep this in mind that if there are n numbers, then there will be n-1 number of passes. So if we consider a list of 10 elements, then there will be 10 minus 1 equal to 9 passes. Now the question will arise, what are passes? One pass denotes the traversal of the entire list, and the end of each pass we will have the last element in its correct position. So if we are sorting in ascending order, we will have the highest number at the last position. And after each pass, we will only consider the remaining elements, ignoring the last element for the next pass. Now let's come back to our example. We have 10 unsorted elements here, and we will perform bubble sorting in ascending order. So this will be our pass 1. At first, we will compare the first pair, that is 5 and 1, and here 1 is less than 5, so swapping will be done. And after swapping, we will get this list. Now the next pair is 5 and 7, where 5 is less than 7, so here no swapping will be needed. The next pair is 7 and 11. Again 7 is less than 11, so no swapping is needed. Next pair is 11 and 2. Here 11 is greater than 2, so swapping is needed. So after swapping, the list is here. Next 11 and 9. Here again 11 is greater than 9, so swapping is done and the list is here. Next pair 11 and 6. Here also 11 is greater than 6, so after swapping we get this list. Next 11 and 15. Now here 11 is less than 15, thus there will be no swapping. Next 15 and 10. Here again 15 is greater than 10, so there will be swapping, and after swapping we get this list. Now the last pair is 15 and 8, and 15 is greater than 8, so there will be a swapping and we will get this list. So this is the end of pass 1, and we can see here that after pass 1 the highest number has been placed at the end, that is in its correct position. So for the next pass we will not consider this last element. Now we will start the second pass. For pass 2, we will consider only the first 9 elements. Here the first pair is 1 and 5, where 1 is less than 5, so there will be no swapping. Next 5 and 7. Here 5 is less than 7, so again there will be no swapping. Next the third pair is 7 and 2, where 7 is greater than 2, so there will be a swapping and we will get this list. Next 7 and 9. Again 7 is less than 9, so there will be no swapping. Next 9 and 6. Here again 9 is greater than 6. So there will be a swapping and we will get this list. Next, there is 9 and 11. Again 9 is less than 11, so no swapping. Next pair 11 and 10. Here 11 is greater than 10, so there will be a swapping and we will get this list. Next comes the last pair for pass 2, that is 11 and 8. Again 11 is greater than 8, so there will be a swapping and we will get this list. Now this is the end of pass 2, and we can see that after pass 2, the second highest number, that is 11, has been placed in its correct position. So for the third pass we will not consider 11. Now we will consider the third pass, and for the third pass we will consider only the first 8 elements. In the third pass, the first pair is 1 and 5, where 1 is less than 5, so there will be no swapping. Next pair 5 and 2. Here 5 is greater than 2, so again there will be a swapping and we will get this list. Next pair 5 and 7. 5 is less than 7, so no swapping. Next pair is 7 and 6, where 7 is greater than 6, so there will be a swapping and we will get this list. Next pair 7 and 9. 7 is less than 9, so no swapping. Next 9 and 10, where again 9 is less than 10, so there will be no swapping. Next pair is 10 and 8. Here 10 is greater than 8, so there will be a swapping and we will get this one. Now we have reached the end of third pass, and we can see that 10 has reached its correct position. Here comes the fourth pass, where we will consider only the first 7 elements. The first pair here is 1 and 2, where 1 is less than 2, so no swapping. Next 2 and 5. Again 2 is less than 5, so no swapping is needed. Next pair is 5 and 6. Same thing, no swapping needed here also. Next pair is 6 and 7. Here also no swapping is needed. Next 7 and 9. Here again no swapping is needed as 7 is less than 9. Now comes the last pair of fourth pass, that is 9 and 8. Here 9 is greater than 8, so there will be a swapping and this one is the updated list. We have reached the end of pass 4, and we can see here that 9 has been placed in its correct position. Now begins pass 5 with only the first 6 elements. The first pair is 1 and 2, where no swapping is required as 1 is less than 2. Again next pair also 2 and 5, so 2 is less than 5, so there will be no swapping. Again 5 and 6, here also no swapping is required. Similarly for the next 2 pairs 6, 7 and 7, 8, there will be no swapping. So we have reached the end of pass 5, and next we will start pass 6 with the first 5 elements only. The first pair here is 1 and 2. There will be no swapping here as 1 is less than 2. Similarly for the next 3 pairs 2, 5, 5, 6 and 6, 7, there will be no swapping. So this is the end of pass 6, and we will start pass 7 with the first 4 elements. The first pair in pass 7 is 1 and 2, and there will be no swapping as 1 is less than 2. Similarly for the next 2 pairs, that is 2, 5 and 5, 6, there will be no swapping. And here ends the pass 7. Now starts pass 8 with the first 3 elements. The first pair here is 1 and 2, so there will be no swapping as 1 is less than 2. Similarly for the next pair 2 and 5, there will be no swapping, and here we have reached the end of pass 8. Here comes the last pass, that is pass 9, and in this pass we will consider only the first 2 elements. As only 2 elements are left for the pass 9, so there will be only one comparison here. As 1 is less than 2, so there will be no swapping. We have completed all the passes for the bubble sort and we have got the list which has been sorted in ascending order. Now that we understand the basic bubble sort, let's talk about optimizing it. In its standard form, bubble sort makes multiple passes through the list, even if the list is already sorted. This can waste time, especially for nearly sorted lists. If we observe the last 5 passes, we can see that no swapping operation has been required since pass 5. So here we can minimize the number of passes. Actually, we can observe that the list has already got sorted right after pass 4. As we can see that no swapping operations have been done in pass 5, so we can stop the procedure there because we have already obtained the sorted list. Thus we can conclude that if there are no swaps in a particular pass, then we can discontinue any further passes as the list has already got sorted. And that's a wrap on our today's video. In this video, we have seen how a basic bubble sort works, and we have also seen an optimized version that can save your time in certain scenarios. If you found this video helpful, don't forget to like, comment and subscribe. Your support helps me create more content like this. And as always, if you have any questions or topics you would like me to cover next, drop them in the comments below. Thanks for watching.